Hi, I'm Celine. Today I'm going to be explaining an IB Paper 1 question. This is the code to the question in case you want to look it up and try it yourself. I cannot put the question due to copyright reasons, but I highlighted the main points throughout my slides and I provided all the necessary diagrams and elements of the question. As you can see on the diagram on the left, a block rests on a rough horizontal plane. A force F is applied to the block and the block moves to the right. There is a coefficient of friction, mu dynamic, a dynamic coefficient of friction giving rise to a frictional force, F, between the block and the plane. The force P is doubled. Will the coefficient of dynamic friction be unchanged or greater? Okay, to refresh on some terminology, the coefficient of dynamic friction is the force between two objects when one of the objects is moving. In this case, it's the block. Normal force is the component of a contact force that is perpendicular to the surface that an object contacts. In this case, normal doesn't mean ordinary, it just means perpendicular. Here, the normal force would be mass times gravity because that's what's perpendicular to the surface. Mass is unknown and gravity is always 9.81 on Earth. So the pull is a force that causes an object to move towards the person who's pulling the object. We can see that it is moving to the right and being pulled to the right. The answer is A, where they both remain unchanged. This is because the force of friction is R, which is the normal force, multiplied by the dynamic coefficient of friction. In this case, normal force is mass times gravity. The coefficient of friction relies on the nature of two surfaces. If the nature does not change, which it doesn't in this case because it's not an inclined plane, it's a flat surface, therefore the coefficient does not change. And doubling the pull is not going to change mass or gravity. Therefore, the coefficient of friction is not changing and the frictional force is also not changing. The answer cannot be B because that is implying that the force of friction is changing, which is impossible because mass and gravity are staying the same. It cannot be C because it also implies that mass and gravity are changing, and it implies that the nature of the surfaces is also changing, but the block and the ground are still the same. And then the final one implies that the nature of the surface is changing, but mass and gravity are not changing. So the only option left, which satisfies both requirements, is A. Therefore, the answer is A. The coefficient of dynamic friction and the normal force all play into the frictional force and are interrelated. However, the pulling force is a separate entity and it does not impact the frictional force or the dynamic coefficient of friction. Those are reliant on the surfaces themselves and the nature of the surfaces, gravity, and the mass of the surface that is perpendicular. The key takeaway from this question is that doubling the pulling force will not change the frictional force because mass and gravity stay the same, and it will not change the dynamic coefficient of friction because the nature of the surfaces stay the same. Thank you.